Okay, so what we're going to do is we're going to talk about the motion of charged particles in uniform fields. So what we have done previously in the topic of electric field, we talk about whenever you leave a charge stationary in a uniform electric field, let's say you leave a charge stationary here, it will start to accelerate in the direction of the electric force. So since it's attracted to the positive plate, it will accelerate over here. So whenever you see a charge stationary and start to accelerate in the direction of the electric force, then the equation to use is this. So W equals to QV, which is W is the energy change, right, gain in KE. And if you want to find the speed, you can change the KE to half mv squared. Change in KE is half mv squared minus initial KE, which is 0, then you find the speed. Now this is what we also just learned regarding a charge entering perpendicular to the magnetic field. So it will move in a circular motion, so FB equals to FC, so you get this equation. So each of these case, there's an equation. So you're going to learn something new, which is a uniform electric and magnetic field simultaneously, which is what we call as a velocity selector. So why is this called a velocity selector? Because this setup can enable us to choose whichever speed of the ions or the charge that we want. So what we do is this, we start off with the same setup as the magnetic field here. So in this magnetic field, when the electron enters the magnetic field, it will experience a force, which is magnetic force, which is downwards. You can use a Fleming's left hand rule. You'll notice that FB is downwards. So if you don't apply an electric force, it will move in a circle. But let's say we want this charge to move and pass straight through undeflected. That means we must be able to balance the magnetic force downwards. So we use an electric force upwards to balance it. So to balance the magnetic force, the electric force upwards means how will we draw the electric field now? So since your electric force is upwards, but the force is on a negative charge. So electric force on a negative charge is upwards, so the field must be downwards. Because remember, the direction of the electric field shows you the direction of the force on a positive charge, but it's opposite the force on a negative charge. So if the force on a negative charge is up, so the electric field is down. So if these two are the same, then the electron will pass straight through undeflected. So whenever you see the question involves the charge moving undeflected in a region with both electric and magnetic fields, then the equation is Fe equals to Fb. So you write down Fe equals Fb, so electric force is Eq, magnetic force is BQV. So when you equate these two, the Q can cancel and the V equals to E over B. That means those charges that have this speed of E over B, they will pass straight through undeflected. But what happens when the speed is greater than that? So we can block it off, or if it's smaller than that, we also can block it off because they will not pass straight through undeflected. So we can use a pair of collimator slates, which means that those are passing straight through can pass through both slates. Those that are curving will be blocked off by the slits. So those that come out will have this speed. That's why we call it a velocity selector. Now, for those that curve upwards, is the speed greater or smaller than E over B? Or if it curves downwards, if the speed greater or smaller than E over B? We can actually use back this formula to decide. Because whenever your speed changes, you must remember that Fe, which is Eq, will not change. Electric force is independent of speed. But your Fb, which is BQV, that depends on speed. So if V equals to E over B and it passes straight through undeflected, if your V is greater than E over B, your Fe won't change, but the Fb will increase. So it means Fb will be bigger than Fe. So Fb is bigger than Fe, will curve down. So this will be speed is more than E over B. But if the speed is less than E over B, your Fe again doesn't change, but the Fb will decrease. So if Fb decreases, your Fb will be smaller than Fe. So Fe will be bigger, so it curves upwards. So then this speed will be less than E over B. So you need to be able to predict as well which one is the one moving faster or moving slower when it curves up or down.